All right, since I was an idiot and tore my patella tendon, I'm not here, and you have a wonderful sub. So behave yourselves. If you get kicked out of class and written up, that's a really poor decision because I'm siding with her and not you. Okay, so you're going to have a quiz over special right triangles and Pythagorean theorem and its converse, and here's some review. So let's start with special right triangles. Now, as a reminder, your two base triangles are your 45, 45, 90 triangle, which is an isosceles right in terms of classifying. So as a reminder, your legs are both equal lengths, and your hypotenuse is the length of the leg times radical 2. So now, okay, I'm not going to restart my computer. We also have 30, 60, 90 triangles. And no, this is not drawn accurately, but I'm sure you'll get over it. So as a reminder, everything is based off the length of the short leg, which is opposite the 30-degree angle. Your long leg, so short, we have our long leg, which is opposite the 60-degree angle, and that is the length of the short leg times radical 3. Remember, radical 3 is just a fancy way of saying the square root of 3. And your hypotenuse is, and for goodness sake, you should know what the hypotenuse is by now. Your hypotenuse is the length of the short leg times 2. Okay, so for instance, let's say I'm told that my length of my hypotenuse is 5 radical 2. Well, I have to remember that the length of my legs is just the number in front of the radical, so it's just going to be 5 and 5 for the lengths of my legs. Hi, Tara. I've printed some stuff to the first floor teacher workroom. Can you go grab it?
Yeah.
And if you actually listen to this, I'm sure you love all that commentary of people I'm randomly talking to. So let's see. If I start with the hypotenuse, let's say my hypotenuse is the length of 18. I have to remember that the short side, my short leg, is half of that length, so it would be divided by 2, so that'd be 9. And then my long leg, the side opposite of 60, is going to be my short leg times radical 3, so this will be 9 radical 3. Okay. The only way that this gets tricky is when you have, let's say, your hypotenuse is just a even value. So let's say it's 8. Well, I know that my short leg, or that the normal relationship for my hypotenuse is the short leg times radical 2. So I have to algebraically solve this. So my hypotenuse equals this relationship normally, the short leg times radical 2. So I have to solve for my short leg. Now, normally that would give you an approximation. This will give you a decimal. But you have to remember that radicals don't play nicely with that. Okay, so you multiply by the radical over itself because you're just multiplying by 1. When you multiply by fractions, you multiply straight across. So I'll have 8 radical 2 over square root of 2 times square root of 2 is the square root of 4, which is 2. And 8 divided by 2 is 4. So that's the length of both of these legs, 4 radical 2, 4 radical 2. Okay. All right, now let's say that for my 30, 60, 90 triangle, on the other hand, that I have a number without the radical 3 on my side that's opposite of 60. So again, let's say 18. So instead of the hypotenuse, this time it's the long leg. So again, I have to use algebra. Algebraically speaking, my long leg is the short leg times radical 3. So I start out with that. My long leg equals the relationship. So again, divide by radical 3 on both sides. Just like earlier, we multiply by the radical over itself. So times radical 3 over radical 3. You multiply straight across when you're dealing with fractions, and I'm going to use the commutative property in switching the order of these. So I have 18 radical 3 over 3 times 3 is 9. So I have 18 radical 3 over the square root of 9, which is 3. So that'll give me 6 radical 3. Thank you, Tara. I really appreciate that. Good for now. I'll call if we need. Yep. Thank you. So my short leg is 6 radical 3. You got to remember your hypotenuse is always twice that amount. So when you multiply that, you have to multiply by the number in front. So that'll be 12 radical 3. Okay, that's all the review I'm going to do is special right triangles. Now when you're dealing with Pythagorean theorem and its converse, we're classifying triangles by their side lengths. And I left, unless someone erases it, you'll have the triangle types on the back board behind my desk, which that's stuff you've learned in 4th and 5th grade maybe, so it's really something you should know. All right, let's say Pythagorean theorem and its converse. All right, so you're given side lengths. So let's say I'm given side lengths of 5, 12, and 13. Well, for some of you, you're going to recognize this is a Pythagorean triple. But let's say you don't recognize this or you don't have good number sense, you don't remember that stuff. That's okay. You always have to remember your Pythagorean or your hypotenuse is going to be the largest side. So with Pythagorean theorem, it's your leg squared plus the other leg squared equals the hypotenuse squared. So I have 13 squared, and I just put the legs on the other side. 5 squared happens to be 25. 14 squared is 140. Sorry, 12 squared is 144. 13 squared is 169. Well, hey, that happens to equal each other. So if they equal each other, it happens to be a right triangle. So in this case, it would not just be a right triangle, but since we have 3 different side lengths, it would be a scalene right triangle. All right, let's do another one, and let's base it off of 5, 12, 13. So instead, I'm going to do 5, 10, 13. So once again, if I'm using Pythagorean theorem in this case, I have to think to myself, well, 13 would go in the hypotenuse spot, and those would be my legs. But in this case, 5 squared is 25, 10 squared is 100, 13 squared is still 169. 125 is demonstrably less than 169. It does not equal it. Well, if your 2 legs are smaller than the hypotenuse, you have a different type of triangle. And hopefully, if you remember this, you'll remember that this and since I'm on pain medicine right now, I'm making sure that I'm telling you this right. Yeah, okay, I am right. All right, that it gives you an obtuse triangle. So if your leg squared plus your leg squared is less then your hypotenuse squared, you have an obtuse triangle. Okay, so let's change the situation. Let's change it instead to, instead of 5, 10, 13, let's say we have 6, 12, 13. So once again, I plug these into the Pythagorean theorem. So 6 squared plus 12 squared equals 13 squared. So I have 36 plus 144 equals 169. Okay, so I believe that'll give me 180, and that is greater than 169. So in this case, if our a squared plus b squared is greater than our hypotenuse, we have an acute triangle. Okay, and that's all you really need to remember. If your leg squared plus your leg squared is less than the hypotenuse, or the largest side, you're going to be able to be dealing with an obtuse triangle. If your two legs squared and added are greater than the hypotenuse, or what's the largest side, you have an acute triangle.